Welcome to Math 219, Multivariable Calculus. Today we're going to be talking about three-dimensional coordinate systems. So we're going to be doing a practice problem, an example of a sort of problem that you might expect on a celebration or something like that. If you want us to run through any more practice problems, then feel free to post on the forums and we'll be more than willing to help you out. So what we're going to try to do is we're going to try and find the radius and center of this particular sphere represented by this equation here. Now at this time, if you want to pause the video and try to solve it to yourself, feel free to go ahead. I'm going to give you a moment to do that, and then I'm going to come back and I'm going to solve it myself. So, yeah. All right, so the first thing that we're going to want to do is we're going to want to take a look at the general form of a sphere, because that just becomes a little bit useful when we actually want to try and solve this for its center and its radius. So pretty much any sphere, well, one second. Probably seen this equation before at some point. This is just the general form of a sphere, and if you look at it a little bit, it might remind you of the distance formula. So this equation, if you actually take the square root, it does of the both sides, it ends up giving you what the distance formula is. It's the set of all x's, y's, and z's that are this fixed distance r away from a point A, B, C. So if we're able to take this equation and translate it to an equation that looks like this, we can very easily see what our center is and what our radius is. And the way that we're going to do this, if you remember probably back from sometime in calculus or algebra, is through a method called completing the square. So let's take a look at the original equation really quick. So first off, we are going to want to look at all of the different x terms. So we can see that x squared is there, but there isn't any like plus 6x or minus 6x or anything like that. So x is already pretty much set. So I'm going to write this. So this is just starting to copy down this equation again. So immediately we can see that the center of this sphere, wherever it is, has an x-coordinate of 0 because there's no other x terms over here. And this is already that first term. So now here's where we're going to have to complete the square. Now notice we have the y term over here. So we have a y squared term, which is what we need for this. But we also have this minus 6y. Now, in order to actually translate that into something like this, we're going to have to use the completing the square method. So I'm just going to go ahead and group the terms really quick. Plus y squared minus 6y. So I just did a little bit of regrouping of these terms really quick. So this is, again, the exact same equation that we had before. All I've done is rearrange the terms a little bit. I've had these little spaces in there, and I changed the x term so it's going to be in the standard form that, of a sphere that we're familiar with. Now, we want to ask ourselves, what other term do we have to have in this y squared minus 6y in order to get it in the form of some y minus b squared? So I'm going to do a little bit of expansion of this out right now. So let's go ahead and take a look at y minus b squared. If you go ahead and expand that out, you get y squared minus, let's see, by, and then another minus by, plus b squared is equal to 0, or y squared minus 2by plus b squared is equal to 0. So this is just the expansion of that standard form that we had before. So if we want to complete the square, we need to have this extra plus b squared term in there. So this minus 6y term is our minus 2by term, and then we need to add in this plus b squared somehow. The question is, how can we do this? Well, let's go ahead and figure out what b is equal to. So it's pretty straightforward. Negative 6 is equal to minus 2b. b is equal to 3. So we're going to need a plus 9 in there somehow. And the easiest way to do this is just to add 9 and then subtract it. OK, so now we've got y minus 3 squared in there. If you go ahead and factor that out, you end up getting, if you just reverse the steps, y minus 3 squared. And you can do something very similar over here. So z squared plus 8z, in this case, let's see, we have negative 2c is equal to 8, c is equal to minus 4, and c squared is equal to 16. So very similar steps, plus 16 minus 16. Yep. OK, so these are all completely legitimate steps. All I did was add in 16 and subtract 16, which is the same thing as adding 0. So if I go ahead and regroup these terms again, now remember, this entire term is the same thing as y minus 3 squared. And then I'm going to go ahead and bring out the minus 9 and minus 16. OK, so all we've done is regroup a couple of different terms. And we now have something that looks very close to this general form of the sphere that we ultimately want to arrive at, which will allow us to give us the center and radius of the sphere. In fact, we already have the center of the sphere. X is equal to, or A is equal to 0, B is equal to 3, and C is equal to negative 4, minus a minus. So, yep. And in order to get r squared, all we have to do is add these terms over. So 9 plus 16 is 25. So 25 is equal to r squared, and the square root of 25 is 5. So therefore, the center of our sphere is 0, 3, negative 4, and the radius of our sphere is, as we stated before, 5. So that is how you use the completing the square method in order to find the center and radius of a sphere in this sort of form. Basically, ultimately, what you just want to do is you want to try and get the equation of the sphere into as general a form as you possibly can. And using this completing the square method, it's is the way that you typically go about doing these problems. So, yep. So this concludes the practice problem on three-dimensional coordinate systems. Once again, if you have any more questions, feel free to post something on the forums. If we can do another practice problem or anything like that. And yeah, so thank you very much, and I'll see you in class.